Okay, so what we've been working on is figuring out how to compile high-level programs into our beta instruction set. We're sort of doing this one to sort of see how compilation works, but the other thing we're trying to do is make sure that we have everything in the instruction set that we need. I hope one thing that maybe you'll be struck by is that our instruction set is actually very straightforward. There's some arithmetic and Boolean and shift operations, some compares, so the sort of ALU operations, and then there's load, store, and branch. That's sort of it. We've taken care of most things. We know how to do loops using our branches. We know how to access memory with loads and stores in order to get the variable values, like in this case n and r, from memory into the register so that our arithmetic operations can work on them. One thing we don't know how to do, and that's really the topic for today though, is if we turn things into procedures, and in this case what I've done is sort of rewrite the factorial, the little iterative factorial loop that we had, now into a factorial procedure. We'll want to think about what our conventions are for assembling that. What's the right assembly language sequences the compiler should generate to handle procedure calls and returns and the passing of arguments. And so they're reusable code fragments, and one thing we have to think about is if, particularly in the case of recursive calls of some sort, will we need to start executing another copy of the procedure before we finish executing the first copy of the procedure? And the answer is certainly in recursive procedures. This is not a recursive procedure. In fact, this procedure has no internal procedure calls at all, but many procedures halfway through their execution call another procedure, and we'll want to make sure that our scheme for dealing with procedure calls and returns can handle nested procedure calls and recursive procedure calls, which are just a special case of nested procedure calls. Procedures have a single named entry point, so one of the ways that we encapsulate functionality in a way that makes its reuse much easier is that we come up with a very specific specification for what the function does. You give me one integer argument, as in the case of factorial, and I'll return to you an integer answer that is, then I'll give the expression that my function will compute for you. And we don't typically end up writing code that jumps into the middle of the procedure. We really only expect to use procedures by jumping to the first instruction and passing figuring out how to pass the arguments. We jump to the first instruction, and at some point we expect the procedure to return to us. And procedures are almost always parameterizable, and that's a very fancy word meaning that we tend to pass in some arguments, some values that the procedure will use and will manipulate. So instead of writing a separate procedure for fact of 3 and fact of 2, factorial of 3 and factorial of 2, we actually have one procedure that will offer to compute factorial of n if you'll only tell it what n is. So that's what we mean by parameters. Many procedures have a certain amount of local state. And so in this case we have a local variable r, and by what I mean by local variable is that r doesn't really exist except when you're in the body, when you've made a call to factorial, and then it goes off and creates it figures out what location in memory to use for r, initializes to 1 and things like that. And the thing again that's complicated about this is that if we have nested procedure calls, or in this case recursive procedure calls, you can imagine that because inside of the execution of one factorial there may be other calls to factorial, we'll see that in a second, we realize that at any given moment there might be several copies of r, each one local to the instance of factorial. So factorial of 3, which might end up calling factorial of 2, at a certain point in time, there's sort of two copies of r that are around. One for the fact of 3 routine, and a second one that got created when we call fact of 2. So we're going to have to figure out how to make all that work. So a lot of the most straightforward ways of doing procedure calls, of which we'll try one in a second, fail for various reasons, and then we're going to have to come up with a better convention. Okay, and as I say at the end, one of the things that happens with procedures is there's a transfer of control, but there's the expectation that the procedure will return to the caller, and then execution will resume right after the procedure call.